Welcome to Summarize Science, where we dive into the mysteries of the cosmos. Today, we're looking at a study that explores why some spiral galaxies suddenly stop producing new stars. The research focuses on 12 local galaxies to understand the role of stellar bars in this process. Many spiral galaxies have a straight, bar-like structure of stars and gas cutting across their center. These bars are not just decoration, they act like cosmic stirrers that move gas around the galaxy. This movement of gas can trigger a sudden burst of star formation or, eventually, lead to its complete stop. When a galaxy stops making stars, astronomers call this process quenching. The researchers identified a specific group of galaxies that have quenched centers but still have active outer edges. This suggests that the quenching process happens from the inside out, starting right where the bar is located. To see this happening, the study utilized data from the Sloan Digital Sky Survey and the Galaxies Space Telescope. By looking at ultraviolet and optical light, they can tell where stars are young and where they are old. Ultraviolet light is a great indicator of hot, massive young stars that haven't lived long yet. In these postage stamp images, you can see the 12 galaxies that were the focus of the study. While they look like typical spirals, their light tells a story of a changing internal environment. Some show bright centers, while others appear more muted and red, indicating older stellar populations. The researchers found that the galaxies in their sample represent a missing link or intermediate stage. They aren't fully dead or quenched yet, but they are clearly on their way. By mapping the colors across the galaxy, the study showed that the bars themselves are significantly redder than the outer disks. This graph shows the color of the galaxy as a function of the distance from the center. The transition from red at the center to blue at the edges is very clear in almost every case. The red regions indicate stars that are typically older than 1 billion years. A common question in astronomy is whether giant black holes are the ones shutting down star formation. The study checked the masses of the central black holes in these galaxies to see if they were the cause. However, they found the black holes were too small to be the primary reason for the quenching observed here. This leads to the conclusion that the stellar bars themselves are the main drivers of this change. The bars funnel gas toward the center, creating a final starburst before the fuel is completely exhausted. Once the gas is gone, the center goes quiet and the galaxy begins to age and turn red. In summary, this research highlights that internal structures can determine a galaxy's fate just as much as external forces. The 12 galaxies studied provide a rare look at the before and after of galactic quenching. In the future, higher-resolution observations will help confirm if this pathway is the same for all barred galaxies. Understanding these pathways helps us map the history and the future of the universe we live in. Thanks for watching Summarize Science.